Here's question number 38. A Boolean function f of ABCD equals to pi of 1, 5, 12, 15 is to be implemented using an 8 by 1 multiplexer, 8 to 1 multiplexer. Here A is MSB, most significant bit. The inputs ABC are connected to the select inputs S2, S1, S0 of the multiplexer respectively. Which one of the following options gives the correct inputs to pins 0, 1, 2, 3, 4, 5, 6, 7 in order? Okay, so here we are supposed to use the Boolean function given to us and implement it using a 8 to 1 multiplexer, which means 8 inputs to 1 output multiplexer. Okay, so let me just get another sheet of paper here and we'll work it out. Right. We start with the Boolean function given. F of A, B, C, D, and the value is 1, 5, 12, 15. Now we have to write this in terms of min-term expression. So if we convert that, sigma m of all the terms, now here it is A, B, C, D. We have 4 terms here, 4 variables A, B, C, D, which means that this is going to be a 4 by 4 K-map with 16 cells. So if there are 16 cells, so it starts from 0, we count from 0 to 15. Now the numbers here are 1, 5, 12 and 15, which means in terms of min-term expression, all the rest of the numbers would be written here. 0, 2, 3, 4, 6, 7, 8, 9, 10, 11, 13, 14. These are the numbers. Next step, write down the K-map. Draw the K-map, draw the cells, put down the values, and then we simplify. So our K-map is going to have 16 cells. A, B, C, D. Now here the value of this cell would be 0, 0. This column 0, 1, 1, 1, 1, 0. This side we would have 0, 0, 0, 1, 1, 1, 1, 0. The cells are numbered 0, 1, 2, 3. Please check. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the cells are numbered from 0 through 15 and we have it divided for A, B and C, D. Now for each of these numbers here in the min-term expression, we put down the value 1 in the corresponding cells. So at 0 we have 1, at 2 we have 1, 3, 4, 6, 7, 8, 9, 10, 11, 13 and 14. The remaining cells will take on the value of 0 and these zeros correspond to the numbers here. 1, 5, 12 and 15. 1, 5, 12 and 15. Okay? Now the next step is to note down the truth table. The truth table is drawn from the K-map that we just worked out. Okay? So we have our columns A, B, C, D, F and F. Now, small letter f here denotes the value of the min-term expression that we drew in the in the K-map, and capital F denotes the input to the multiplexer. Okay? So now let's write down the values from 0 to 15 in this portion here. Those are the binary values. Alright, so here you will see that I have written the values from 0 to 15 in binary numbers for A, B, C and D. Now I'm going to group them in 2s. The reason is because our final input, capital F, for the multiplexer will be determined based on these pairs. The question tells us that the variables A, B, C are connected to the select lines. D is left out. So that means that A, B, C are supposed to be the same. Now you will notice that for the first two, A, B, C is the same, only D changes. For the next two, again A, B, C is the same, D changes. For the next as well, A, B, C are the same. So that is why I have paired them up in 2s. Okay? So now, let's fill up the part of F. Now this is the min-term expression. We had F is equal to the values being 0, 2, 3, 4, 6, 7, 8, 9, 10, 11, 13 and 14. For all of these numbers, the value will be 1. So exactly there, let's put down 1. For 2 it is 1, and then for 3, 4, 6, 7, 8, 9, 10, 11, 13 and 14. The rest of the values will be 0. So this is what we have. Now for the final part, F. Okay, so F depends on D. So you will have to note that F depends on D. Very important. Now look at the first part. Now the first pair, A, B, C are connected to the select lines. So let's leave that as it is. Now observe D and F here. 0. When D is 0, F is 1. When D is 1, F is 0. So you see the values are opposite, right? That means that the input is D bar. Complementary of D. Complement of D. Complement of 0 is 1, complement of 1 is 0. So the input is D bar. Now let's look at the next part. The next part here, 0. When D is 0, F is 1. When D is 1, F is 1. So regardless of the change, F is 1, which means that the value, the input for this portion is 1. Now look at the next part. When D is 0, F is 1. When D is 1, F is 0. Again, it's the opposite or complementary. D bar. Next, 0, 1, 1, 1. Regardless of the change, F is 1, which means the input is 1. The next one as well, input is 1. The next one as well, input is 1. Now look at this. This portion here, for 0, it is 0. For 1, it is 1. So F equals D. The input is D. And finally, for 0, it is 1. For 1, it is 0. That's D complement. So the input here, the inputs for 0, 1, 2, 3, 4, 5, 6 and 7, the value is D bar, 1, D bar, 1, 1, 1, D, D bar. These are the inputs. And this matches let's check option B. Well, this is the final answer.